Hello everybody, Oded is here. It's a pleasure to have you on this webinar. This is the third webinar by Sanjeev. Sanjeev have incredible knowledge and experience in developing and implementing CCPN in many places around the world. His development and his views provide significant insight for those of us who are working with critical chain, and for those of us participating that are considering bringing CCPM on board for their environments. Today is on the important subject of the planning, and to you, Sanjeev.
Thank you, Oded. Hello, everyone. And so as Oded has already mentioned, the purpose or the subject of today's webinar is project planning. So I will dive right into it. And the format will be, I will present, focus on one missing link in project planning, which is what is a task in a project plan. So there have been a lot of discussions over the years about what is a task. It is clear that the task should not be too small, it should not be too big, but what should a task be? Right? So apart from some rules of thumb about, hey, the task should be between 1 week and 2 weeks, there is nothing else that is out there which helps you define a task from the perspective of what will enable good execution and good management of the project. So hopefully in today's webinar, we will be able to bring some clarity on this subject. And just to start with, I have this very simple question here, right? So if you were to score on a scale of 1 to 5 as to how well do project plans do their job. So first of all, when we think about project plans, a lot of times in people's mind, the job of planning is only to provide reliable estimates of cost and timelines and resources. But for execution, people assume that you will never use the plan anyway. Execution is going to happen through spreadsheets, through their own local schedules, through checklists, through to-do lists. But for execution, people normally don't think that a project plan is going to do the job. And from a control perspective also, in terms of understanding what is the status, people management is not as if management gets updates on the plan and then goes into the plan and sees where the status is. They always rely on interpretations of experienced managers below in terms of what is the status of the project and whether we need to worry about something or not. So if I were to put a score of 1 to 5 in management's mind, planning, if you get good project planners, project plans do a fairly good job. They might give it a rating of somewhere between 3 to 5. For execution, they will say it is not applicable. For control, they will say, yes, from the project plan, we cannot ever get good reports. There's a lot of massaging that goes on, so maybe the score is low. And it would be good for all of you who are on the webinar to just take half a minute to just put down your score in terms of on a scale of 1 to 5. Now, the main, most interesting thing for me is that in my mind, the main purpose that a plan should fulfill is guide execution, right? Getting an estimate of cost and timelines and resources, in my mind, is a secondary benefit. Getting a control is important, but the first and foremost purpose of a plan, by definition, has to be to help people execute in a synchronized way to achieve a certain goal. And when I talk about synchronized execution, this is not anything new to you, but just to recap, because this will set the stage for what defines a good task, is imagine that you have two projects. Both the projects are similar. There is a red task, there is a golden task, there is a blue task in the project, and there are two projects going on. Now, when we talk about synchronization, what we mean is that the priorities of the red and the golden department should be synchronized. If the priorities are not synchronized, meaning department red is giving priority to the project on the top. The golden department is giving priority to the project on the bottom. Then both the departments will do the work, but the project cannot move forward in the sense that you cannot integrate the golden and the golden and the red outputs. You cannot perform the integration blue task until both of them are done. Of course, what is desirable is synchronized, that golden and the red departments are giving the same priorities to the same projects. And it is in this regard that our project plans utterly fail us. Right? And of course, the benefits are very clear that if you are able to operate in a synchronized way, you achieve a cycle time of 10 days for each project instead of an average of 17 and a half days, which is 15 days for the first project and 20 days for the second project. And the throughput is also higher because in the same amount of time, you could start a third project and finish it. So synchronization is an overlooked but most important function of a project plan. Now, we know this theory, but this is just to bring everyone on the same page, that we know that you create project plans, and one of the major reasons they fail in execution or to synchronize execution and why people do not follow project plans is that the uncertainties cause these project plans to fall apart. Your tasks change, your sequence of the task is changing, requirements are changing, you need to do multiple iterations, resources are not available, etc., etc., etc. And bottom line is the plan becomes invalid the moment you start executing, so people put it on the side. We also know that the whole idea of critical chain buffer management was a breakthrough in this regard, but it is my experience and our experience from about 350 multi-project implementations and about 500 large construction projects that we have helped manage or manage directly, that buffer management is a very incomplete answer in terms of making plans useful in execution because of two reasons. One is what buffer management does is that as you report task completions or task progress or the remaining duration on the task, it is recalculating the priorities. If your project plan is very detailed or not done correctly, then buffer management switches priorities too often. So what might happen in a very simple software project is you are working on feature number 1 and feature number 2, and the critical chain will switch from feature 1 to feature 2. So neither feature 1 is done and you have started feature 2 already. So buffer management can cause a switch in priorities very fast. Same thing happens in construction projects, same thing in engineering projects. So this is one problem with buffer management that needs to be solved. The second major problem is that buffer management does not solve the practical problem that a lot of times your tasks themselves can change. A lot of times you do not know the tasks that you have to perform, and the dependency between the tasks is not rigid. So when we create a project plan, it's not as if these dependencies are rigid. Sometimes there is flexibility in the dependencies. Ideally, you would like to do the civil design first before you do the mechanical design, but you can do it in the reverse order also. Ideally, you would like to follow a very strict sequence for some activities, but you can do them in parallel. So the sequence or the dependencies also can change in execution. And with buffer management is not enough to keep the plan alive. Now you have to go into this constant planning and replanning mode, which again renders the plan useless. So even if you have buffer management running, but if you have to change your project plan every day or every 2 days or even every week, then it becomes a useless tool and people put it on the side. So we have seen that a lot where you go and implement critical chain, people are very enthusiastic for a few months and they put all the energy into keeping the plans updated. But after a few months, they get tired of constant planning and replanning and they revert back to the old methods. And this is why we have created a concept of two-tiered tasks. And this two-tiered tasks in our experience provides the missing link in keeping the project plans alive. So buffer management is half of the breakthrough, and two-tier tasks is the other half of the innovation that really makes project plans useful in execution. And the concept is pretty simple, and this is what I will illustrate through the examples. The concept is that in terms of the detailed work, day-to-day work, or the assignment of work that needs to happen to people, those are what we are calling subtasks. But similar subtasks that should be executed together, they are clubbed under a higher level task. And your critical path or the critical chain is running at not at the subtask level, but at the task level. What it means is many things, but just to make sure that it is there's no confusion, that in the traditional PERT network, so for example, if you pick up Primavera or Microsoft Project or any other software, so the traditional PERT network critical path is always running at the lowest level of the task. With a two-tier tasks, your critical chain does not run at the subtask level. You can put the subtasks in, but your critical chain still runs at the task level. And this is the trick. Finding out, defining what is a task is what we have found is the most important thing in the planning. It is not what the size of the buffer should be. It is not when should a buffer turn red, yellow, or green. Those are minor things. Those are almost chup checks, if I were to use Ellie Goldratt's words. So how much the buffer should be, when the buffer should turn red, yellow, green is a chup check. What is the most important thing in project planning is defining the task at the right level. And it is not that task should be between 1 and 2 weeks long. We have done construction projects, for example, large infrastructure construction projects, where tasks are about 4 to 6 months long. So in a project plan, a critical chain plan, there are tasks that you can have that are 4 to 6 months long. And a lot of the details of execution, day-to-day execution, are thrown into the subtasks. So hopefully with the examples that I will share with you, it will help you get some rules, some ideas about what should be a task and what should be a subtask. I've tried to classify the knowledge that we have so far. So still we are at a classification stage. We are not at the cause and effect stage of the knowledge. But in terms of classification, these are the 7 classifications I will walk you through in terms of that help us kind of think through what should be a task and what should be a subtask. So we'll pick up each one of them one by one, but here's a summary table for everyone's reference later on. So the first one example is interactive work. So the example of interactive work is, imagine that you are designing a turbine. And when you are designing a turbine, this is a turbine that is used for power generation. So turbine, there's a compressor which sends compressed air into the turbine. There is a casing outside it. And the compressor blades and the turbine, the compressor and the turbine and the casing, there's a lot of interaction between those designs. How you design the blade of the turbine should be accounted for in the casing and in the compressor. So ideally, what you want is, even though the turbine is being designed by a different engineer, compressor is being defined by a different engineer, casing is being defined by a different engineer, there is a continual flow of information between these designs. So you want to share information between these 3 designs as you move forward. And to give you an idea, these designs are pretty long activities. They can take somewhere between 2 weeks to sometimes even 6 weeks. So what can happen is that if you have a delay in the compressor design, so you might create a very synchronized plan where the turbine and the compressor and the casing design is happening in parallel. With an execution, there might be a delay on the compressor design. So now suddenly everything is out of sync. So the problem is, how do you ensure synchronized execution of these 3 different designs without creating very complex dependencies. And the solution is actually pretty simple, which is this is how we ended up defining the task in this case. So we said there's a task which is blade 1 design. Under that, there are 3 different activities that need to be done. And each of these activities are fairly long. So these are not like 1 day or 2 day activities. These are activities that can go on for 2 weeks, 3 weeks, up to 6 weeks. And you create a hard dependency between blade 1 and blade 2. Theoretically, the turbine blade 1, once you finish it, theoretically the engineer who is doing the turbine design can move on to blade number 2. But we are saying don't move to blade 2 until all the 3 designs are done. And when it is done, then you pick up the next task. So in this particular case, we were able to take what they thought was a good critical chain project plan from about 600 tasks down to about 50 tasks when we applied this thinking in their design process. And this is another place to mention that, when Eli Goldratt was writing the strategy in practice tree the first time, so when he wrote critical chain book on the simulators and initial knowledge, his recommendations was that project plans should not be more than 200 tasks or 250 tasks. So, right, but of course that doesn't make sense. If you have very small projects, then 250 tasks is too many. But to exemplify the point, we were taking complex projects and we were creating project plans that were between 150 to 200 tasks. And when we started using this 2-tier idea, we were able to take the same project plans and convert them from 200 tasks down to about 40 to 50 tasks. So this is one example where there is interactive work. So what we are saying is all the interactive activities should be subtasks, and their grouping together is a task. And a similar example for interactive work is, imagine you have a situation where you have to do casting and you have to do some fabricated parts. So castings have long lead time. So after you do the design, you need to send them to the vendor. So there's a long lead time with that. Whereas the fabrications, they have short lead time, so they can be done later. But in reality, the casting design is affecting the clip and mounting and fastener design and vice versa. So there's again a continuous flow of information between casting and the fabricated parts. So a traditional critical chain plan might look like there are 2 chains of activities where one chain can be started later and finished later for the short lead time activities. And traditionally you would break the project plan into long lead design and short lead design. Versus what we have found to be much more effective is to do the casting and the clip design together. So if you have 3 castings, for example, so there is a design group 1, design group 2, design group 3. So you are not dividing the work based on the lead time. You are dividing the work based on the interaction. Right? So very similar situation to before, but the contrast here is that traditionally you would take the project plan and you would have long lead time design and short lead time design. But that creates a lot of rework, because after you are done with the casting design, and when you go and do the clip and mountings and fasteners design, if there's some design decision here that has to affect the casting, then you end up doing a lot of rework. So this was another example. The next one is interacting resources. So the idea for interacting resources, this is not exactly the same as interactive design. In the interactive design or activities, there is flow of information. But the idea behind interactive resources is, imagine that you have to do simple drawing. So you are in the detailed design phase. So you have done the major high-level design and you are now just producing drawings. So there's typically drawings. After drawings are done, you would do a review. Based on the review, you might have some rework and one more review and an approval. Now, there will be many such work streams inside a project. So you do drawing, review, rework, review, approval for work stream 1. work stream 2, etc., etc., etc. Now, what the traditional critical chain can do is, if I define my project plan with these activities, what it can do is it can show different priorities for different resources. So for example, for the red resource that one has to do an approval, it might show that something else is on the critical chain because they are supporting this project and maybe some other project on which the buffer is running, being consumed at a faster rate. And it will cause desynchronization. So which means the drawing is done, but now you have to wait for the review. After the review is done, so you send your comments back, but now the engineer is busy on some other task, so you have to wait for the rework. So they start and stop and start and stop and start and stop at every activity, and this causes your project plans to extend too much. And the solution is very simple. We say that work stream 1, the entire work stream, the entire 5-step process is one task, not 4 or 5 different tasks. Right? So again, the idea here is that I could have defined, because again, these activities, some of them can be long. So instead of having each of these activities, because there is a resource handoff involved, even though there is a resource handoff involved, I'm not going to declare them as separate tasks. I'm going to club them as subtasks under a higher level task. So, which brings us to the another interesting point, that a lot of times when I look at a project plan, a good measure for me is that if I see tasks that are done by one resource, then I know instinctively that there is something wrong with the project plan. So a lot of time, good project plans, the tasks in those project plans are multi-functional, multi-resource tasks. Because when you have multi-resource tasks, then I know that someone has thought through the interactions and the interacting resources and thought about those things and put them together. So whenever there is a task which is done by an individual resource, that is a red flag to say we need to, maybe the project plan is not good. A third example, which is again very interesting, is microassembly, right? So let's take the example of shipbuilding. So shipbuilding is pretty simple. Ship is nothing but you cut a lot of plates, you fabricate them, you make subsections, and then you fabricate sections, and you take different sections, and you assemble the ship. And after this ship is done, then you do outfitting, electrical, plumbing, all the other outfitting things that you need to do. But the basic ship is nothing but a lot of steel cut and welded together. Now, to take a very small ship example, you might cut a set of plates, you fabricate them into a subsection, then you fabricate those subsections together into a higher level section, and then you are fabricating those multiple sections into the ship. And even for a pretty small size boat, this can run into a few thousand plates per ship. In traditional PERT, you can get fooled into thinking that, hey, the ship has no uncertainty. We know exactly what plates to cut. We almost know how much time it will take. So let's create a very detailed project plan down to the plate level. And that is going to be the best project plan. In reality, what will happen is any of the delays will start causing desynchronization. So what you end up with is a lot of plates that have been cut, but you cannot do subsections because some plate is missing. Or a lot of subsections have been fabricated, but you still cannot fabricate the entire section because one of the subsections is missing. And same thing at the ship level. So there's a lot of waiting at the assembly points in a typical ship. So the way to capture this project plan in our experience is that all the cutting for a specific section, so this orange section that you see, all the plates that need to be cut for this section should be cut together, because you don't want this flow from cutting to fabrication of the section to get interrupted at any point because one of the pieces is missing. So you cut all the plates, and that is one task. And the fabrication of subsections are, again, not tasks but subtasks. The fabrication of the entire section is another one task. Right? So again, this is just to illustrate the idea that what you want to do here is, the main thing you're trying to avoid here is this micro synchronization problems. So you don't want some parts of the project to be missing and the project to stop. And the definition of tasks is going to be based on what synchronization you are trying to achieve or force in the project plan. Right? Again, to make the point that I could have captured all these details in a critical chain network and used buffer management to try to achieve synchronization. But that is a myth. What buffer management might do is it might give priority to plate number 1, and then it might give priority to plate number 5, then it might give priority to plate number 7. So it will create a lot of partially finished work which cannot be taken to the next step. So this is the example of microassembly. The fourth example is batching. So, right, so this is a little bit not counterintuitive, but if you come from a manufacturing background, you think batching is a bad idea. In projects, sometimes actually batching is a good idea. So let's take the real life example here. So you're trying to, again, either disassemble a ship that has come in for repair, or you're trying to assemble a ship. And all these items are very heavy. So you need pumps, valves, panels, piping, gears. All these things need to come together, and you need a crane to stage these heavy items. And the actual time that is needed by the crane is not too long. But setting up and tearing down a crane takes a significant amount of time. If I have a project plan with all these 3 times 5, 15 tasks, what might end up happening is the crane will keep moving between different areas. So it might do some work in area 1, then it will move to area 2, then it might move to area 3, then it is needed back in area 1, and so on. Right? So that makes the entire process very inefficient. A better way to define these tasks is that you do staging for area 1. So all the things that are required for area 1 work, they get staged together, and the crane goes there and finishes the work. So it's that simple. So you took 15 tasks and you combined them into 3 tasks, with other 15 tasks not going into the subtasks. So the point again is that, okay, maybe the point that is emerging out of this is that project plan is not just a definition of activities and dependencies between those activities. A project plan is also about, when you are executing, thinking about what is the work that you need to see executed together, that should stay together in execution, and defining tasks accordingly. And I see my colleague Michael Hamlin has also joined. So Michael, you should feel free to interject as you deem fit. Okay, another interesting example is enforcing an execution sequence. So imagine that you are building 3 rooms. This is the house you are building, and there are 3 apartments, and in each apartment there are 3 rooms. So total of 9 rooms you have to build. You can literally build, and let's say they're all on the same floor. They're all on the ground floor. So it's not that the apartment 1 is above apartment 2 and apartment 2 is above apartment 3. All the 3 apartments are on the ground floor. So literally, I could go and work in room A, and then in room B on apartment 2, then in room A of apartment 3. So I could follow any sequence I want. But so actually I described the situation wrong. So the situation here is there are 9, these rooms are actually on different floors. So if an apartment is not completely floored, it stops work in that apartment. Sorry, give me just 1 minute.
Yes, Sanjeev, let me take.
Yeah,
right?
sure. Go ahead.
Right. This is Michael Hamlin.
Yeah.
Right. So in construction projects, what happens is oftentimes, right, so you have all these different subcontractors, and until the subs finish their work, right, we really can't move forward and complete anything. Right, so I have a lot of different areas that can be worked, and if I leave it up to their own individual schedules, whether this is a sub or even my own crews, if I leave it up to their own schedules, then what I have is I have a lot of work going on. And in this case, I have a situation where I may start work in one room in one apartment, and I'll get that done. Then I will go ahead and pick up and maybe move to that same room in another apartment. So let's say I take the kitchen and do the flooring in the kitchen first. And now I want to move from kitchen to kitchen to kitchen. Well, until I get all my flooring in, now I can't come in and do my finishing work. So what happens now is my finisher is stuck sitting there waiting for flooring to get all the kitchens, then all the living rooms, then all the bathrooms done in all three of these apartments, and it's handed off as 3 rooms at a time. So the downstream resources are stuck sitting there waiting. Where really now what I want is I want the flooring person to come into apartment 1, get all that done. When they move to the second apartment, now my finisher can come in and do their finish work right behind. And so even the downstream can move much faster, and the overall project can get done much faster.
Thank you, Michael. Thank you. So maybe you want to explain this one also, Michael. Carry on.
Very good, very good. So the other side of this is that oftentimes in execution, exactly when I need to have things done needs to have some flexibility. If I try to, in this case, let's say I'm in a construction and I need to do some, but this is on the design side of it, and I need to do some civil design work around the grounds and structural, these kinds of things. Then I have the mechanical design that has to happen, and finally the electrical design. And I think intuitively, because the way I'm going to build this structure, then I really want to do my civil design. Then so the civil can start. Then I want to do my mechanical design because they're going to come in afterwards to do the structural building. And then finally my electrical is going to come in once it's all framed, and they're going to do their electrical work. But the reality is that based on the downstream designs, what happens in my mechanical, it could affect my civil. It could change loads, these kinds of things. Based on what my electrical has, it could change how my mechanical has to be designed, because now I have to route things differently, or what was a support beam now has to have a hole drilled in it, and it can no longer be classified as a support. So there's a lot of, this kind of gets back to the interaction, but I think I want this flow, but reality is I need some flexibility. Instead of scheduling them one at a time, really what I want to think of it as is this multifunction task of one design, and all the design is being done at the same time. So now as designs are happening, I still have each individual set of tasks or activities that have to be done by each one, but I'm doing the design all at one time instead of stretching it out. This final one is, we called it the rolling wave planning, right? Or maybe very similar to the Agile approach. We've all been in these kinds of situations where as I'm developing my plan, and maybe let's say this is a long plan, a year long. I have a good understanding of what I'm going to do for the next few months, but going beyond that, I don't know right now. And in many projects, what's going to happen in month 4, 5, and 6 is going to be driven by what happens in month 1, 2, or 3. Right? So I think this is a pretty simple and very common situation for people, that I need a way to be able to plan in this rolling wave manner. So in other words, as I'm finishing some work, the next things are being decided up front, but I don't want to go through a whole entire lengthy replanning process, right? So instead of breaking this up into different streams, Sanjeev, if you can, right? The solution here really is that I need a planning methodology that allows me to build the higher structure. And in this case, it's really what is at the module level. But the details underneath, I need to be able to update them real time without going through an entire replanning process. So I need a structure that gives me a roadmap of, what is this project and how long is it going to take? But now with the 2-tier task approach, I can add the details of each of these tasks as I go along.
Thanks, Michael. So to recap what the various examples, and now Michael will also show you some real project plans in this 2-tier structure. that from different environments. But these are the 7 different cases we covered where you need 2-tier tasks. So it's not just about whether the task should be 1 week or 2 week long. It's about how should the detailed activities be grouped together into tasks which will constitute the critical chain or critical path project plans. Before we move into the actual plans, are there any questions? Nereus, if you don't mind, can you open it up for questions?
With your example of 3 microassembly showing just 2 tasks, cut all plates, build section 1 with subsection built as tier 2 task. Would you wait to build the first subsection, a subtask, until all plates are cut for all the subsections? I guess I'm asking, do you use full kit rules at tier 1, or you can do full kit at tier 2?
And I think the question really you are asking is, should I cut all the plates for all the subsections before I move into the fabrication stage? And the short answer is yes.
Ian, hello.
Hi there.
Yeah, so you are on. Can you clarify your question or just repeat it?
Well, that was a clear answer. So if I'm right, Sanjeev, you do not start fabricating subsection A, then subsection B, until you have cut every single plate for the whole of section 1. Could that by itself add to time?
That is very good. So in theory, it looks like it will add to time. In reality, it will save you time because you will have all the inputs that you need to start fabricating. Right? So the time it takes to fabricate and the time it takes to cut the plate is not a lot. The time really is spent in waiting, and that is what we're trying to minimize here.
Okay. Yeah, that's clarified. So in cases where wait time is the major part of the project plan, then it makes sense to operate your full kit at tier 1. Thank you.
Yeah.
The other thing, let me add to that, Sanjeev, right? Because the other thing that happens is a lot of times as they're cutting the plates, right, these are big sheets, and we're trying to minimize the wastage, right? So of course, as they're laying out the cuts of these plates, then what happens is they may be grouping the cuts and you may, so what happens is you have 80% of what you need for section A, 70% of what you need for section B, and 30% of what you need for section C. Until you're all done, it's hard to get 100%. Once you set up and started fabricating, now if I don't have everything, then I'm just completely stuck. I'm stuck sitting there waiting. So this is how you gain that time, because you really got to wait for all the plates to be cut to have 100% of what you need.
Great. That's useful clarification, Michael. Thank you.
Okay.
That's very good.
That's
very good. And also, you don't want, yeah, so I think, Michael, this is what you were saying, but to take the point a little bit further. So when you are doing the fabrication, you don't want there's interaction between the plates. So there might be, if you have all the plates together and then you start fabricating, then you can make adjustments in the way you are fabricating stuff or in the way you are assembling the plates together to allow for minor discrepancies between what your design was versus what the actual cutting of the plate was.
great. Thank you. So then we have the question from Sutap. How do you plan tier 1 without detailing out the tier 2?
I'll give you an analogy from a very different example, which is you are driving your GPS system. It doesn't need to know when you will change the lanes, when you will need to stop for a light, when you will need to stop for the car in front of you. But the GPS system can still create an overall planned route for you to get from here to there and even adjust that route as conditions change. So you really don't need to know a lot of the details of tier 2. And in fact, that is the trap that you want to avoid getting into. The moment you get into thinking about tier 2, then you get paralyzed, because a lot of times those details cannot be known, or those details will keep changing. Or if you ask 3 different people, they'll give you 3 different answers about those details. So you really don't want to get down to tier 2. You really want to stay at tier 1 level if possible. Michael, you want to add something to that?
No, I think you did a great explanation. I think in my experience, what I found is it's actually easier for people to think at the higher level of, okay, if I need to deliver this end output, it's going to take me 2 weeks. When I start getting into the little individual micro details, I really don't know exactly, is this one going to take 2 days, and then because of that, the next one's going to take 3 days, or oh, wait a minute, maybe if I spend 3 days on the first one, then the next one will only take a day. It's such a fine minutia that's going, and those things are going to change based on what's happening. But when I really stop and think, okay, to do this, I need 5 people, they need this skill set, and we'll be done in 2 weeks.
Yeah. And to add to that, Sutap, so I kind of know a little bit about your environment or your, what project environment you are in. So you are in software projects, right? So the biggest harm that Agile has done in the world of software projects is estimation of story points, right? So by breaking an epic into chapters, into stories, and then doing estimates at the story level and adding those estimates back up is the most destructive thing that Agile has done in addition to time boxing. If you go to Gartner, I will try to find a report for you, but what Gartner is beginning to recommend now is that do not go down to stories to do story point estimates. You should do your project level estimation at the level of epics or chapters, but don't break it down into stories to do the estimates. Right? So that is what Gartner is recommending for IT projects. And not to berate Agile completely, Apple is moving away from time boxing because they found that time boxing has created so many problems in their product that they're moving away from time boxing, the idea of time boxing.
So let's switch to Michael's computer, yes?
Can you see my screen now?
Yes, you are on.
Okay. So I've got a few different project plans that I will share with you. And I won't go into, a lot of detail on them, but we'll cover the idea of the 2-tier tasks. I'm going to cover what would be kind of a typical engineering, new product development, or engineer to order environment. I'll also cover an aircraft maintenance example, and finally I'll cover a thermal power plant. So kind of different complexities of projects. Okay. But the idea of the 2-tier tasks is, taking into account the different scenarios that Sanjeev laid out for you earlier of really, now how do I go and group these activities together? So here I have a development of a solar panel, if you will, or a solar array that's being developed, right? So this involves doing some design work, then procuring the materials for that, and finally doing the assembly of the solar panel itself. Okay, and in terms of the engineering, I have different streams. Not everything's in series. I have different streams of activities that have to happen in parallel. Right, but you can see now that what was in their original plan as about 30 to 40 different activities or tasks that needed to be done in engineering. This has now been grouped into only about 10 different tasks that have to happen. And to different degrees, they have different numbers of subtasks underneath them. But I'll take one as an example here, what they call this preliminary analysis. So they've done some design work at this point, and it's time for the first analysis. And a challenge that they had from this analysis was it involved many different resources doing several different activities. And not that there was a lot of effort involved here, but typically because people were busy and priorities were shifting, it would take a long time to get this analysis completed. Right? And you can see now by grouping this together, right, and identifying first what are the different resources that are needed. So I have some things that are done by a mechanical design, some that are done by a structural analysis, and a little bit of thermal analysis to be done as well. By grouping all of this work together, what typically before was taking almost 8 weeks to complete has been shortened down to, they feel they can get this done in about 4 weeks. So just this individual activity alone, and was shortened significantly. And underneath this, right, we say it's in parallel, but you'll notice that there's no tasks in here that are actually the 20 days. And the reason is because it's not that things have to happen one after the other. It's not a perfect sequential. The exact order at the time of planning is not known. They haven't even done the design at this point. So exactly the order in which they need to do this analysis is a little bit unknown, but they know these are the steps that they need to go through. So this is one of those examples where they said, if we want to do this analysis, we know we need these types of people, these skills, and it's going to take us about 4 weeks to get it done. Okay, so this gives them the ability to plan at the high level, but still identify the different tasks that need to be done. And these are the activities that they will assign in execution to get done. And exactly when they need to start each one of them is something that they'll decide in real time every day.
Yeah.
Along with these tasks, right? One of the things that they know, not only do they want to focus at the task level, they also want to focus engineering. If you remember the example Sanjeev gave with the castings and the fabricated mounts and clips, they suffered from the same thing. There are some items that are long lead materials. They need to get them out there because they take several months for the vendors to build. They have some medium lead and some short lead. So they used to build their schedule based on this, but one of the things that it led to was either rework or compromises, right? And you know, when you're so the next thing they wanted to do is not only focus at the task level, they wanted to drive engineering as a whole to finish as one unit and as quickly as possible. So the project plan allows us to create this hard milestone and force that work to be done as quickly as possible. What is the fastest we can get it done, and how do we focus on it? So now all the design is done before I start releasing materials out to the, and at this point now it becomes a supply chain. I have all my designs are complete, and now I release them to my vendors in the right order based on the lead time. It's no longer engineering is driving when they get released. Now they have everything they need at once.
Yeah. And by the way, the side benefit of that is now in engineering, the project is done. So you don't have high whip of projects in engineering. Even though theoretically you could have waited for some of the engineering could be done later. You have finished it on the shelf. No need to worry about it anymore.
Now the next thing was, as we prepare for the assembly and test, right? Typically they would get a few parts in from the vendors, and they would start setting out their area on the floor, and they would start building. And before they knew it, they had a lot of projects going on, and they were completely out of floor space on the shop. So now, if something was to change, they were stuck. Their floor was full. These are big projects. They couldn't just, decide to put one to the side and start another project. So we integrated this idea of full kitting. Right? This is actually a point in the project where we're strategically saying, I'm not going to move forward until I have everything that I need. Okay. And this now allowed us, again, because we have everything, so now we could even begin to group the activities that have to happen in assembly and test, the same way that we did in design. Overall, this project went from about 270 some tasks in total, to now we're down to, in total, less than 40 tasks in this overall project. So let me move to an aircraft example, right? And using a lot of the same logic. In this case, this is a customer that brings in commercial aircraft and does heavy maintenance checks on them. So when they first come in, right, they first have to do some inspection, some tear down, get the aircraft taken apart and find out what all is wrong with it. And one of the challenges they have is that they don't know what they need to fix until they've gotten through all these inspections. Of course, they have some standard things. There's some life limited parts that they have to replace, but the majority of the work that they have to do is based on what do they find, what problems, cracks, corrosion, all these kinds of things. And what's very common in the industry and happens is that this disassembly and inspection goes area by area and stretches out for a long period of time. In other words, I start to take apart the wing. As soon as I find a problem, I quickly want to get somebody on to start fixing it. Now my focus becomes fixing, and the disassembly and inspections on other areas like the cargo area or the cabin the lavatories, all of this just begins to stretch out. As those inspections take longer and longer, if I find a problem, my time to fix them, get parts becomes less and less. So in this case, what we've done is we've broken the aircraft into the different sections. This actually followed the way this customer was already doing it. We left it in their sections. But instead of creating tens of different individual work instructions for each area, we actually grouped these together by what are they doing, what resources do they need, and what is the area. So if I look at this upper fuselage, right, even though there's 40 different work instructions or work cards, some call it, that need to be done, right, they can get all this done in just 3 days if they have a team, right? So this is the multi-skilled again. I need avionics, the electrical side, I need cleaners, I need folks working the interiors, and I need mechanics. And it's a pretty big group of people I need. So trying to manually make sure that all of these activities are getting done in the right order is very difficult. This is where the software comes into play. And by grouping them together, right, now I've made sure that this team of 14 people are all out there working on the same area of the aircraft at the same time. And then we use a lot of the same concepts, right? Where we brought in the milestones, so we make sure the disassembly or the open up and inspection is done as quickly as possible. We brought in the full kit to make sure that we have everything before we start trying to reassemble or close the aircraft up. And this idea of the rolling wave or the agile approach that we talked about also comes into play here. You'll notice that for most of these repair, they don't have any sub-activities at this point. And that's because as the inspections happen, that will tell me what the repairs are that I need to do. And at this point, as I'm creating those additional repairs, right, the system can automatically take into account what are those repairs and start adding those in here and seeing, can I get them done in this 3 days that I have targeted, or is the amount of repair now going to start impacting the overall flow of my aircraft? Right, so I can take into account this rolling wave, and as I find the problems, I can start adding them. And the last example I'll get to, a little more complicated of a plan, and this is a thermal power plant, right? But again, it breaks down kind of into the same idea. I have different areas or different parts or different streams in the project, right? And I can define each one of those. So if you're used to using, you know, multiple, if you have large projects and you're used to using multiple project plans to try to define that, this is really nice because I can roll it all up into one project plan and I can see it all at one time. Right? So each one of these, in some cases, might have been a separate project in itself, or it may be just even separate work streams within a project. And now, you know, even within engineering, I'm able to start combining the activities just like I did in the smaller project that we looked at. I'm able to start combining the activities that need to be done and identifying the team of resources that are required to get that done. And you'll notice here that, again, I don't have anything that adds up to the 16 days, so it's not a perfect scenario of one at a time, and it's not quite the scenario of they're exactly in parallel. First, we started with, if you have these people, how long will it take? Now, what are the activities, and roughly how long do you think it will take to do each one? But Concerto is using the higher level to actually build the critical path or critical chain. Okay. And to drive each of these work streams, and in this case, many of these milestones are actually tied to customer deliverables. This is the second place that we can use milestones. We want to make sure that we're meeting these customer deliverables, because many times those deliverables may have payments tied with them. So these milestones actually allow us to drive the completion of different streams and make sure we're meeting whatever those customer deliverables are.
Is there a quick way to see the durations of these tasks if you bring up the tabular view? I just want to make a point that, you know, the durations can be many weeks long.
Sure, no problem. So here you can see the remaining durations are, you know, some of the projects I showed you, the durations were small, only a few days. Here I have a task that's only 4 days. At the same time, I have a task that is as much as 60 days or, you know, a couple of months in length, 40 days.
Thank you. Okay, so before we move to the concluding part, let's open it up for questions again.
Yeah, Robert has some questions, and yeah, Robert, you are on. Ask.
Yeah, hi.
Hello, Robert.
Hi, Sanjeev. Yeah, back to your comments on the Gartner report. Did they give you any ideas how to do any estimates?
Just to rephrase the question for people. He asked if Gartner in their report gives any suggestions on how you should estimate the durations. If you're not doing it at the subtask level, how do you come up with the estimate?
Yes. So I'll give you the Gartner answer, and Michael, you can add on to it. So what Gartner is saying from a software development perspective, don't go down to stories to do the estimates. Do the estimates at the chapter level, or maybe even sometimes at the epic level.
Yeah. So I think regardless of the industry you're in, whether you're in engineering product, you're in maintenance, you're in software, construction, right? I go back to the example I gave before. Actually, what I find is people have a harder time trying to estimate these very low level specific tasks, right? How long will it take, if I go back to the GPS, how long will it take me to go from one stoplight to the next stoplight? There's actually a lot of variability in there. Or how long will it be between the times I have to apply my brakes? Even the GPS doesn't measure that. How long is it going to take me to do this specific design? And how long will it take me to do the next specific design? Well, there's so many interactions and uncertainties in there that if I start trying to estimate, I'll start thinking about every problem, every interruption, every design change that I'll come up with. Where really, if I say now, I want to design this entire gearbox, which has many moving parts in it, many analysis that has to happen, I know that I can do that in 2 weeks. Exactly what's going to happen day to day. If I try to think about all the things that could happen, it's not 2 weeks, it's 4 weeks. So I think people really, it's much easier for them to think about, I have to design this feature, I know I can do it in a week. I have to design this hard part, I know I can do it in 4 weeks. I have to, I have to tear apart this entire section of the aircraft, I know we can do it in 2 days.
In your experience, is engineering design or preparing the engineer the main limiting factor or constraint?
Is preparing the engineer?
In your experience, is the engineering design or preparing the engineer the main limiting factor or a constraint?
Can I take that question, Michael?
Sure, go ahead.
So I don't like coming up with general declarations about constraints. I totally disagree when, for example, Ellie Goldratt said management is the main constraint. Who knows? It depends on situation to situation. So constraint is not something you need to theorize and hypothesize about. When you build your project plan, you talk to people, you will know where the constraint is. Sometimes it could be the engineer, sometimes it could be in the supply chain, sometimes it could be as trivial as a drafter. So I don't think there is a general constraint from project to project.
Based on the first question he had, Sanjeev, the one thing I'll add is that in my experience, right, the process of trying to keep people busy, right, this idea of people have to be busy is, I don't want to call it a constraint, but it leads to a lot of extension of cycle times. And what I mean by that is I get a little bit of information, but not everything. And I push people to start, whether it's design, whether it's drafters. I think that's the big piece, is making sure that, and this idea of rolling things together. So the 2-tier, I have everything that I need to go execute this. Now I can get done. Where the pressure today is, I've given you something, just go to work.
Very good. I think great clarification. And this is not very different from manufacturing. You go into a manufacturing plant, you see wandering bottlenecks everywhere, just because of the way they are planning and executing manufacturing. Right. So I guess same thing in engineering or any project, that what you experience is a lot of wandering bottlenecks because of just this idea that let's get started. Let's just keep people busy. Let's just give them some work. And the more work you give to people, the more bottlenecks it creates downstream. To close out the webinar, the point I would mention again is that there is much more leverage in creating good project plans, two-tiered plans, than arguing about buffer sizes and the settings for the colors. So thank you everyone for attending. Bye-bye.